What if I told you that you can find the sum and the product of a polynomial's zeros without ever finding the zeros themselves, just by glancing at the numbers in front? Sounds like a magic trick, but it's a rock-solid rule, and by the end of this video, you'll use it like a shortcut. This is the most exam-loved idea in the whole chapter, so let's nail every piece. Here's the plan. Every quadratic and cubic hides a secret relationship between its zeros and its coefficients, the numbers a, b, c, d. We'll find that relationship for quadratics, prove why it's true, use it on real examples, learn to build a polynomial from its zeros, and then do the same for cubics. Step by step, nothing skipped. Let's meet the star rule. Take any quadratic ax squared plus bx plus c and call its two zeros alpha and beta. Those are just Greek letter names for the two zeros. Then two beautiful things are always true. The sum of the zeros, alpha plus beta, equals minus b over a, and the product of the zeros, alpha times beta, equals c over a. In words, the sum is minus the coefficient of x divided by the coefficient of x squared. The product is the constant term divided by the coefficient of x squared. Watch the minus sign on the sum. That's the number one place people slip. Now, we never just trust a rule at Clarix. Let's see why it works. If alpha and beta are the zeros, then x minus alpha and x minus beta are factors. So the quadratic equals k times x minus alpha times x minus beta for some number k. Multiply that out and it becomes k times the quantity, x squared, minus alpha plus beta times x plus alpha beta. Now just match it up, term by term, with a x squared plus bx plus c. The x squared parts give a equals k. The x parts give b equals minus k times alpha plus beta. The constant parts give c equals k times alpha beta. Divide through and out pops alpha plus beta equals minus b over a, and alpha beta equals c over a. That's the whole proof, clean and honest. Let's use it on a real one. X squared plus 7x plus 10. First, find the zeros the usual way by splitting the middle term. We need two numbers that multiply to 10 and add to 7. That's 2 and 5. So it factors as x plus 2 times x plus 5, giving zeros x equals minus 2 and x equals minus 5. Now let's verify our rule. The sum, minus 2 plus minus 5 is minus 7, and minus b over a is minus 7 over 1, which is minus 7. Match. The product, minus 2 times minus 5 is 10, and c over a is 10 over 1, which is 10. Match. The rule holds perfectly. One more type you'll meet. A quadratic with no middle term, like x squared minus 3. To find its zeros, recall the identity. A squared minus b squared equals a minus b times a plus b. Here, 3 is root 3 squared, so x squared minus 3 is x minus root 3 times x plus root 3. The zeros are root 3 and minus root 3. Quick check. Their sum is 0, and minus b over a is 0 too, since there's no x term. Their product is minus 3, matching c over a. Beautiful. Now let's flip it around. Suppose I give you the sum and product of the zeros and ask you to build the quadratic. Easy. The polynomial is x squared minus the sum times x plus the product. Say the sum is minus 3 and the product is 2. Then the quadratic is x squared minus 3x plus 2, that's x squared plus 3x plus 2, and any multiple of it, like k times that, works too. Quick check. Use the rule, don't solve. For the quadratic x squared minus 5x plus 6, what is the sum of its zeros? A 5, b minus 5, c 6, or d minus 6. Remember, sum equals minus b over a. You have 10 seconds to solve this. Pause if you need more time. Here, a is 1 and b is minus 5, so the sum is minus b over a, that's minus 5 over 1, which is plus 5. Option A. Notice we never had to find the zeros at all. That's the power of the rule. Let's level up to a cubic, a x cubed plus bx squared plus cx plus d with 3 zeros, alpha, beta, gamma. Gamma's just the third Greek name. A cubic has 3 relationships. 1. The sum, alpha plus beta plus gamma, equals minus b over a. 2. The sum of the products taken 2 at a time, alpha beta plus beta gamma plus gamma alpha equals c over a. 3. The product of all three, alpha, beta, gamma, equals minus d over a. Notice the lovely pattern. The signs alternate, minus plus minus as you go down. Quick sanity check with the cubic 2x cubed minus 5x squared minus 14x plus 8, whose zeros are 4, minus 2, and 1/2. Their sum is 4 minus 2 plus 1/2, which is 5 over 2, and minus b over a is minus 5 over 2, also 5 over 2. The product is 4 times minus 2 times 1/2, which is minus 4, and minus d over a is minus 8 over 2, also minus 4. The pattern works for cubics, too. Your turn, and this one's a build it. A quadratic has sum of zeros equal to 5 and product of zeros equal to 6. Which polynomial is it? A, x squared minus 5x plus 6. B, x squared plus 5x plus 6. C, x squared minus 6x plus 5. Or D, x squared plus 5x minus 6? Use x squared minus the sum times x plus the product. Drop your answer in the comments, A, B, C, or D. I read every single one. And that's a wrap on polynomials. You now know what they are, how to see their zeros on a graph, and this gorgeous link between zeros and coefficients that lets you shortcut whole problems. You've genuinely got the full chapter. If Clarix made this click, follow along. We're doing the entire syllabus, chapter by chapter. I'll see you in the next one.